Okay, so we were saying that if we want to reduce our system now to A, okay, we will do the following. We will say that when we put our system at A, it should still produce the same effect about C, okay? So if I want now to reduce at A, I will need a couple and I need the force. Now what is unknown is the couple I should put. What is the couple I should put at A? This is unknown, okay? And I know the resultant force, Fr, I know it. So I will say that to have equivalent systems, the condition is that the moment produced by the system of force and couple at A should be equal to the moment produced at C. Okay, so the condition is that MRC is equal to, first, I have the moment of the force about C. So the moment of Fr about C, and don't forget here to add the couple. But since I choose the counterclockwise as direction for MA, and here my direction in the equation is clockwise, so I will put minus MA. Okay, I will put minus MA, and now I can say that MA should be equal to the moment of Fr about C, which is here. How to find the moment of the force about C at this location? As we said, only the x component is doing a moment because the y component is passing by C. So I have equals to Frx. So it's Frx times the distance, which is, the distance here is 6. So times 6 and minus resulting moment about C. So from here, you will get your value of MA. If you get a positive result for MA, this means that your assumption is true and MA is counterclockwise. And if not, it should be in the opposite. But physically, when you did an analysis, you know that it should be in the counterclockwise direction. Okay? Any question?
Doctor,
Yes.
for the third question, we can نعمل بعد and we calculate the moment of every flow. صح ولا لا?
Christina, I cannot hear you well. Can you repeat?
I will type because there's a lot of noise.
Okay. If you want, you can ask me after. If you want. Okay. Another problem. We have here the slab is to be hosted using the 3 cables shown. Replace the system of forces acting on the system by one equivalent force and couple at O. Okay? So here, always the same method. To find first the resulting force, we do sum of forces. Okay? And to find the resulting moment, we do sum of moment of forces about O. So if you want, try to do this problem as a practice, okay? It is the same we did before, but now in 3D. So you do F resultant equals sum of forces, and you can find the components of F1, F2, F3, as we learned in the first chapters we did together. So for example, here for F3, they gave you the angle with Y, Z and X. So you can write that vector F3, so vector F3 is equal to 4 cosine, with I, look, with I the angle is 60. So 4 cosine 60 along I plus along Y also it's an angle of 60. So plus 4 cosine 60 with J, and plus along K you have 4 cosine 45, so plus 4 cosine 45 along K. So we found the expression of F3. Now for F2 vector, as you can see, they gave you the two projection angles. So you can say that to project on xy plane, I do cosine 45. Then the angle with y is 30. So it's to find the y component, I should do cosine 45 cosine 30. And for the y component, it's cosine 45 sine 30, but you should put minus because as you can see in the figure, the component along x is in the negative. It is like this here. So negative x, positive y. Okay? So I can write that f2 vector is equal to 5 cosine 45, and I will put minus because it's along I, so minus 5 cosine 45 sine 30 along I, while along y it's positive, so plus 5 cosine 45 cosine 30 along j, and along k it's plus 5 sine 45, so plus 5 sine of 45. Okay, while for f1 is the easiest one, it has only a component along z, so for f1 vector it's equal to f1 it's equal to 6k. Okay, and now once you find the expression of your vectors, you will say that the resulting moment about O, so m resultant about O, is equal to sum of moments of forces about O. Okay, so it's equal to, here because it's 3D, it's easier to use the vectorial product. Okay, all you have to do is to select first, look for f3 no moment, because as you can see f3 is passing by O, so 0 moment about O. You still have to find the moment of f2 and of f1. To do this, you choose a point on the line of action of your force. So for example, this is f1. F1 is passing by this point. Okay, so you take any point on the line of action. Here, this is the easiest one, and you say that the moment of f1 about O, if we name this point, let's say this is A, point A, and here this is point B, for example. Okay, you can say that the moment of f1 about O is simply OA vectorial f1. Okay, so here, and for f2 it's OB vectorial f2. So here sum of moments about O equals for f1 it's OA vectorial f1 plus for f2 it's OB vectorial f2. Okay, and plus f3, as we have seen, it is 0 because it's passing by O. So now all you have to do is to find the coordinates of A and B and do the vectorial product. So for example, for A, as we can see in the figure, it is on xy plane. It has a y component equal to 6 and an x component equal to 2. So for point A, the coordinates are 2, 2, 6, 0. While for point B is on x-axis and it is at a distance of 4, because this distance here is 4. So for B it's 4, 0, 0. For B it is 4, 0, 0. Okay, so now to find the resulting moment, all you have to do is OA vectorial f1 and OB vectorial f2. Now let us do, for example, OA vectorial f1. We can use here the matrix method because for OA is 2i plus 6j. So OA is equal to 2i plus 6j. Okay, so if you want to find the moment of f1 about O, we can do or the expansion, or we can do the matrix. So if we want to do the matrix, for example, we have for the first line it's ijk, I, j, and k. Okay, you have the second line is the coordinates of vector OA, so it is 2, 2, 6, 0. And for vector f1, for vector f1 it's 6. Look here, for this first term it was much easier to do the expansion, because look, f1 has only one component along k, so you can do the matrix, but the expansion is much easier. Okay, for OB vectorial f2 you can do if you want the matrix, but also for OB you have one component along I, so also the expansion is easier. So always look if the expansion is easier or the vectorial product. Okay, and use the easiest method. Okay, so here if you want to do the matrix method, you will put as usual plus above I, minus above J, and plus above K. Okay, so we can say that if you are doing OA vectorial f1, it's equal to, along I, if you drop these two, this column and this line, you have 6 times 6 minus 0, so it's 36 along I, 36 along I. Along J you put minus, you have 2 times 6, 12 minus 0, so it's minus 12J. And along K you have 2 times 0 minus 6 times 0, so it is plus 0K. And why it's expected to have a 0 moment along K here? Who will tell me? Because we are finding the moment of F1, and F1 is what? Look at your figure.
It's parallel.
Yes,
Parallel
F1 is parallel to Z, so it cannot produce any moment about Z. So here we found the moment using the matrix method. If you want to use the vectorial method, you can see that it is very simple here, and you will get the same result. If you do the vectorial method, you do 2I plus 6J vectorial, the force, which is 6K. Okay, so now you do the expansion. You have I vectorial K is minus J, and 2 times 6, it's minus 12J. And J vectorial K is plus I, and 6 times 6 is 36, so plus 36I. So you can see that you got the same result, but it is much faster here, because this is because you have here only one component, so the expansion is simple. Okay, so you continue this problem by calculating OB vectorial F2, and you do their summation, you get the resulting moment about O. And to find the resulting force, what should you do? F resultant. How you get F resultant here? What is the
You add the
expression?
component.
Yes, it's sum of forces. Okay, so you should add vector F1, so it's F1 vector plus F2 vector plus F3 vector. You get your resultant force. Okay, any question on this problem? Okay, so please try to practice with these problems. We will continue solving these problems next time. And so during this week, we'll do a revision for exam 2. And after, we will start by a new chapter. Okay? So see you next time. Okay, bye-bye.
Thank you, Doctor. Bye.
Thank you, Doctor.
Welcome.